Okay, welcome to tutorial number 17. So the last tutorial wasn't anything really new, right? We just graphed the way we had graphed earlier in the semester. Well, now, finally, with this tutorial, we're going to use what we learned in our quad unit in order to help make graphing easier. So we're going to look at this graph, and you know what? We couldn't use our old way anyways, because for the first time, we have not only an x squared part, but we have a term that's just plain old 4x. So we don't know how to graph this, but we're going to use our wonderful factoring skills to help us. So the first thing we're going to do is we're going to rewrite, instead of f of x, I want to rewrite this as y, just as a reminder that f of x and y mean the same thing. And I want to tell you about something that's really important with all these graphs that we've been doing with quadratics. The x-intercepts are very, very important in quadratics, and you'll find out, I hate everything's so suspenseful in algebra. You'll find out when you do calculus. But really that's what we're doing. We're preparing our minds and our skills to be able to do calculus. But x-intercepts are really important, just trust me. So we want to know, where does this graph intercept the x-axis? And we think about all the points on the x-axis. Every single point on the x-axis has something in common. If you can't think of it, let's just think of actually points. Like this point, its name is 2, 0. This point's name is 6, 0. This point's name is negative 4, 0. Do you see what all these points, I could keep playing this game all day, right? But do you see what all the points have in common on the x-axis? Yeah, all their y's are equal to 0, right? So if I want to find the x-intercepts for this graph, then I'm going to need to change my y to a 0. I'm going to say, hey, if y is equal to 0, which means I'm on the x-axis, where on the x-axis will this quadratic intercept? So it's a big, big idea there. So we're going to look at the quadratic. If we can graph it the old way, using, shifting the vertex and then using our patterns, graph the old way. That's a fast way and it makes sense. But as soon as you can't graph the old way, we're going to use factoring to help us graph. And so let's ask ourselves, what's in common with this term, negative x squared, and this term? And I can hear you say it. It's right. It's x, right? They both have an x in common. And so we have a choice here. We could go ahead and ignore the negative. We could just factor out the x. In fact, you know what? It might make more sense just to factor out the x and deal with that negative in front of it. It's okay, we can do it. So here we go. So let's factor out the x. Once again, we're still 0 equals. We're going to factor out the x. If I divide negative x squared by x, I end up with negative x, right? If I divide if I divide 4x by x, I end up with 4. Are we good? All right, so I factored, and now I'm in an equation, and we've done this before, right? Where we have something times something equals 0, which means either x is equal to 0 or negative x plus 4 is equal to 0. If I solve, already I solved for 1x over here. If I subtract 4 on both sides, I get negative x equals negative 4. And now you either, I like to think of it as multiplying both sides by negative. Some people like to think of it as dividing both sides by negative 1. However you do it, you're getting rid of the negative, and you end up with a 4 on this side. So what we did was we took our original equation and we plugged in 0 for y, because we purposely did that so that we could find where our x-intercepts are. So we already know 2 points. We know there's a point where x is equal to 0, and there's a point where x is equal to 4. So 2 points does not a quadratic make, right? It'd be tough to figure out which way is it going. So we need, how about 3 more points? The first thing is, can we find our vertex? Let's see if we can figure out our vertex. So let's stop and think about the things we know about the graph of a quadratic. we know that it's symmetrical, right? So if I have 2 points that are directly across from each other, then that means that I've got what's called a line of symmetry right down the middle of them. So let's see if we can do this. And if we haven't talked about that before, because, I'm not sure if I've used that term before, let's go back real quickly to something we did in the other tutorial. Let's look at this. Can you see that for this graph, there is a midpoint? I'm sorry, there's not a midpoint. There's a middle that splits this quadratic right in half, right? And it's interesting, the vertex is on that line of symmetry. It always will be. Let's see if we have another one we can have fun with. Look at this quadratic. Oh, it's a terribly graphed quadratic. So let's look at one of these. That's a really nice quadratic. But let's look at this one. Now, let's look at this. So here, the y-axis is actually our axis of symmetry. So every graph of a quadratic has an axis of symmetry. And on every quadratic's axis of symmetry is the vertex. So what we're going to do is this. We're like, okay, vertex, I know you're somewhere on this axis of symmetry. Now, how do I find out where? Well, we already know one part of the vertex, right? See this number 2? The vertex, whatever it is, its point is going to be 2 comma something. We just don't know the height. We don't know if it's up, if it's down. We don't know the y part of the point. We don't know the y value. So what we're going to do is we're going to go back to this original equation right here, probably where we had the y, but remember f of x is the same thing as y. We're going to solve for y because we're going to take 2 and we're going to plug it in where we see x. So let's see, let me change up, how about red? All right, so here we go. I'm going to solve for y because whenever I see x, I'm going to plug in a 2. And I'm going to remember when I plug in my x, when we plug in my 2, I'm going to use parentheses. So you put this whole thing into your calculator. I'm going to do it in my head real quickly. Well, we'll have 4, and that's -4. -4 plus 8 is 4. So now I know the missing piece. I know that my vertex is located at 2 comma 4. There it is. Let me pick up the green. There it is, right there. So that's pretty cool, isn't it? Let's do, just because we want to be really thorough with our graph, let's get 2 more points. So here's the thing. We already, from our x-intercepts, we already know that we've got the point that's 2 to the right and 2 to the left. Let's go ahead and see what happens when x is 3. So see how there's a 3 here? Let's see what happens when x is 3. What y do I get? So we're going to do the same thing that we did to find the vertex. We're going to use that same idea to find another point on the graph. So here we go. I'm going to take this equation. It's getting a little crowded here. And I'm going to solve for y when x is equal to 3. So every time I see x, I'm going to put in a 3 and use parentheses. And then either I'm going to use my calculator or use my brain. So let's see. That'd be a -9 plus 12. That's going to give me a 3. So that tells me on this graph, when x is 3, y is 3. 1, 2, 3. And you know what that means? Because we already know that quadratics are symmetrical. That means when x is 1, y is also 3, right? Because if y is 3 when I'm 1 away from the axis of symmetry, then when I'm 1 away from the axis of symmetry on the other side, y will also be 3. And then finally, amid the mess, I can connect my dots, and there you go. So it's a little more complicated, isn't it? But we don't have a choice. We can't use our old ways, and so we had to come up with a new way. And this is a fine way to go about doing it. What did we get? We figured out our x-intercepts first. Then we noted where our line of symmetry was. And then we said, hey, where's that line of symmetry going through anyways? And we noticed it was going through where x is equal to 2. And we said, oh, I wonder what y is when x is equal to 2. And we went ahead and plugged it in. And we found out we had 4. And that's how we got 4 here. And then to fill in and get 2 more points, we plugged in 3. And that's where we got 3. Yes, it is methodical. It's got a method. And with practice, we're going to get really good at it. So let's practice another one. All right, let's look at this. We know that we want to find the x-intercept, and the only way to do that is to plug 0 in for y, because every point on the x-axis has y equal to 0. And so when we look at this, we're like, ooh, I remember these. We are so good at factoring these. Two numbers that when multiplied together equal -10, but when added together equal -3. What are you guys thinking? How about -5 and +2? Does that sound good? -5 times 2 is -10. -5 plus 2 is -3. Sounds good to me. And now I've got something times something equals 0. So I'm going to go ahead and set each one of them equal to 0. So either x is equal to 5 or x is equal to -2. Now remember, we just found the x-intercept, so we know where they belong, right? They belong on the x-axis. So here we go. Let's find the 5, and let's find the -2, and let's see if we can find the middle of 5 and -2. So why are we going to find the middle? That's our next step. We're like, well, we found the x-intercepts, so now let's go ahead and find the axis of symmetry, because quadratics are symmetrical. So let's see, we're going over 1, 2, 3, 4, 5, 6, 7. No! Our axis of symmetry is not going to be pretty. All right, we can handle this, right? So let's see. The middle of 7 is 3.5. So either from your left point or your right point, you're going to go over 1, 2, 3.5. And you get right there, right? 1, 2, 3.5. Do you guys all agree that right here is your axis of symmetry? Now, I'm not perfectly aligned here with my smart board, so I'm fighting, trying to keep that in the center. So there's our axis of symmetry. It's not pretty, but we can handle it. So what is x at our axis of symmetry? It is right there, 1.5, right? So this point right there is 1.5, or we can use 3/2. You can use whatever you want. So we're going to go ahead and I'm going to need a calculator for this. I'm going to have to make a run for the calculator. So what we're going to do is this. We're going to say our vertex is, the x value is 1.5, and we don't know what the y value is. So let's find out. Let's go ahead and plug. Let's see. Let's plug in 1.5, and we see x minus 10. All right, I'm going to take off my mic, and I'm going to run for the calculator. You guys run for your calculator too, and let's do this. All right, you guys might even have the answer by now. I wish you could tell me. I wish I could hear you through that screen. All right, so we've got 1.5 squared, and then we're going to subtract from that 3 times 1.5, and then we're going to subtract 10 from that, and I got negative 12.25. So this is a bummer, isn't it? We're going to have to extend our graph. And you know, if you have to do that in the test, you have to do that in the test. So that's negative 11. That's negative 12. It's going to be a little bit lower than negative 12, right? Negative 12.25. We don't have to be exact. We're just going to try our best. So negative 12.25 is about there. Okay. And so we could go ahead and sketch our quadratic, which is the 3 dots, but I always like to do 5 sets. So let's go ahead and note, we're going to pick something easy. Like we could pick either, wouldn't it would be awesome if we picked 0. We could find, you can pick anything you want. How about what's y's value when x is 0? So I'm going to go back to the equation. And I'm going to plug in 0 when I see x. Love plugging in 0, right? That makes it easy. I don't have to go running for the calculator. So I get y equals -10. So when x is 0, y is equal to -10. So let's go ahead and graph that. And you know what it means if since quadratics are symmetrical, 0 is 2 away from the x-intercept. Then the other one, when I look at the right, that's 2 away from the x-intercept, would be right here, where x is 3. So when x is 3, we're going to also have a point at -10. It's all symmetrical. Beautiful and symmetrical. All right. And there you have it. Not easy, but not too difficult. It's something we can do. We can definitely challenge ourselves to practice this and get better at this. All right, and our last question, I believe, is asking us to look back at problem number 2 and find where the graph has a y value of 8. So let's see. Let's go ahead and do what we did before and copy our graph. And so many things are in the way of our graph. Let's see if I can move some stuff. Ooh, that was nice. Okay, I'm going to copy our graph like I did before. Not like that, though. Okay, let's see if I can get a good copy of it. And we'll bring it with us. And okay, so we're going to bring it with us so you can look at it. There's our graph. And it says, where does the graph have a y value of -8? So we're, maybe you drew a better graph than I did, but looking at this graph, I can't really tell. It looks like when y is equal to -8, I'm kind of here and here. So I may guess, if I was going to do a guess, I would say my answer might be, okay, this is just a guess, I'm just writing it down. -2, -8, and this one looks like close enough to 4, 8. But I don't know that. So that's why, that's a perfect example of why we need to do it algebraically to double check if our graph is right. So here we go. We've done this before. My graph is covering up. I don't know what the instruction says. A y value of 8. All right, so let's plug in 8 for y, and let's go ahead and solve. This is not a square root problem, right? And we're not going to solve this using square roots. We're going to solve this by factoring. So we're going to get everything on one side so we can have a 0, because we can't factor unless we have a 0, right? So I brought the -8 over, and now let's go ahead and factor. So we'll have what? How about x minus 6, x plus 3? Does that work? -6 times 3 is -18. -6 plus 3 is -3. That works. Now we can use the multiplicative property of 0 and set them both equal to 0. And solve for x. All right, so how far off was I? Oh, I was really far off, wasn't I? All right, this says it happens at 6. All right, so yeah, I can see that if I drew this a lot better, and maybe if you drew it better, maybe yours looked good, but basically it says 6, -8, so it really should be here. Now that looks suspicious. That doesn't look really right, but let's see. A -3, -8. Yeah, that doesn't do it for me. Something doesn't look right about that. So let's see. If I've got that, I'm double checking my work. -6 plus 3. That's looking good. All right, at some point here, I made a mistake. So what I'm going to do is I'm going to pause it and see if I can figure out why our graph doesn't look good. That does not look convincing that our answer makes sense. So hold on, and I'm going to pause this, and I will be right back. Okay, you guys probably already figured it out before me. It's because the graph was covering up the question that I went to -8 instead of 8. So this answer does make sense. These points down here don't make sense because they weren't asking me where the graph has a value of -8. They're asking me where the graph has a y value of 8. Okay, Miss Overby, get your questions straight so you can answer them correctly. All right, so does this make sense? Let's look at our answers again. So it's 6 and negative 3. So let's see. When x is 6, could we be up to 8? Absolutely, that's believable. Look, if we extend that, look how close that is. Totally believable. How about negative 3? Negative 3 up to 8? Yeah, we probably have to bend a little bit more, but that is believable. So once again, we have to write our answers in coordinate point form. So these are the 2 points on the graph that are that have the y values equal to 8. So sorry about that misleading, looking at the negative 8s. I think if we would have predicted, if I would have been trying to predict where the graph is, had values of 8, we might have come close. I think we might have picked negative 3 and 6. All right, that was fun. Or I'm sorry, yes, negative 3 and 6. That was fun. Let's practice more. I'll see you in marker board groups. And thanks for joining me. See you in the next tutorial.